We're team number 13917, Zoobotics, carbon oxides from Kalamazoo, Michigan. We would like to share with you our journey this year as we made efforts to become the ideal FTC team. Our team history started in the 2017-2018 season with two 8th graders. We currently have two teams. This year is our largest team, but due to the challenges of the COVID-19 pandemic, we had almost half of the members drop out at the start of the season for safety reasons. At the end of this school year, we plan to recruit for next season at the local elementary and junior high schools. We also plan to start a first LEGO League team in our area this year to get even younger kids excited about robotics and engineering. On our team, we pair the 6th graders with the 8th graders to help mentor learning and development. In terms of adult mentors, we have been fortunate to have parents with backgrounds in engineering and programming. We remain thankful to our sponsors who have given us the opportunity to see the STEM field in the real world through tours of their facilities. We invited a mechanical engineer with a 30-plus year career to present at one of our meetings. These STEM connections inspire us to explore and expand our engineering knowledge.
This season, we utilized the engineering design process to build our robot. We spent countless hours researching and brainstorming to come up with a plan. We've analyzed and made adjustments as needed. Due to the ongoing COVID-19 pandemic, we had to implement a strategy that divided the robot into modules or components. This allowed us to assign each team member a module to be able to work from home or independently as needed in addition to our regular scheduled meetings. Then we brought each component together piece by piece to build the whole robot. Additionally, we learned to create 3D computer models using Autodesk Fusion 360. This was really difficult at first, but it was worth the effort because we could work in addition to our regular meeting times and change or optimize our designs before using these for our 3D printed parts. After each of our 2 qualifying tournaments, we made a continual improvements to increase our average score. We improved approximately 10% between our first and second tournaments. In preparation for the state tournament, we identified 4 main action items for additional improvements to our robot's performance. We are hoping for a 20 to 30% improvement for the state tournament. We achieved beyond our goal with an average match score of 423 points, a 40% improvement.
In designing our robot, we want to be functional, efficient, and look cool. After we analyzed the game, we decided our main strategy is to quickly cycle the shooter to get a lot of high goals. Our top priority was the ring intake module. We spent weeks iterating through different design ideas. We started off with a wide intake like most teams, but ended up optimizing a narrow intake. The final intake design is fast and easy to use. While one motor on the shooter is sufficient for hitting high goals and power shots, we decided to use 2 motors on our shooter for fast sequential shooting of 3 rings. These 2 design elements are the main reason our robot has performed so well. We have not seen many other robots with this combination. We average a very fast 6 seconds per cycle to pick up and shoot all 3 rings. Our robot is a durable robot that can be repaired easily by module. Additionally, all the wires and electronics of our robot are routed well and hidden. We 3D printed parts with team name, number, and logo. We also use black to represent carbon and red for oxygen. We finished the robot design with these accents to enhance our team branding.
The biggest challenge was, early in the process while we were working with the robot and trying to pick up 3 rings and cycle very quickly, was we'd often pick up more than 3 rings. Not only is this a penalty, but due to the design of a robot, this would cause a robot to jam and disable, requiring maintenance. To address this challenge, we need to find a way to track the number of rings going into a robot. This led us to our innovative solution. We used an IR optical avoidance sensor to detect the edges of the rings. This solution is not only fast, but does not require any moving parts. The sensor detects the 4 edges of the ring as it passes underneath the sensor. We increment the ring counter by a quarter for each edge. We are working on a video to explain this process to share on our YouTube channel for the FTC community. Our YouTube FTC channel is used to help share our insight in the robot building season. Last year, we made a detailed video of every single component on our robot and shared them. Those videos received over 30,000 views. We plan to make detailed videos on this year's robot. We know these videos help other teams because we often get questions and comments about our robot. We've even seen other teams use our designs. Sharing our learning is one of the ways we live up to gracious professionalism. We'd love to hear any questions you have for us.